So when I start with number 1, it says find the zeros of the given polynomial. So if I list my possible factors, it would be 25 divided by 1. So I'm going to have plus or minus 1, plus or minus 5, and plus or minus 25. So to find the zeros of this given polynomial here, I'm going to synthetically divide, and I'm just going to start with 1 and see if 1 works. And I get a 0 remainder, so that tells me that 1 is a 0. So for my f of x, remember, if it's a positive 1 here, when you write it as a linear factor, it's a minus. Next, I'm going to check and see if what's left over is factorable. So if this is x to the third, this is x squared. I have no x's and minus 25. That is factorable, so I'm going to have x plus 5 and x minus 5, which makes my zeros 1 and plus and minus 5. So when I go to the next one and I list my possibles, I have plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, and 12. And on bottom I have plus or minus 1 and plus or minus 2. So my possibles, if I divide through, I'm going to have plus or minus all of these, and then I'm going to divide through again by 2. So I get So I get 1/2. I already have 1 because 2 divided by 2 is 1. And then I get 3/2. 4 divided by 2 is 2. I already have that. 6 divided by 2 is 3. I already have that. And 12 divided by 2 is 6. I already have that. So these are all my possibles. So again, I'm just going to start with 1. So I have a remainder, so 1 is not a factor. So I'm going to try again with 2. So 2 works. So when I have my f of x, it's plus 2. So I'm going to get a minus 2. So now I'm going to check and see if this is factorable. So I get 2x to the third plus 3x squared minus 5x minus 6. So if I divide these two by x squared, I have 2x plus 3. If I divide this by negative 1, I have 5x plus 6, so they don't match. So this is not factorable. So I'm going to take this right here, and I'm going to try synthetically dividing another factor. And I'm going to switch. I'm going to try negative 1 this time. So negative 1 does work. So here I get x plus 1. So now I'm going to check and see if this is factorable. So I have 2x squared plus x minus 6. So when I check, I'm going to have a times c, which is negative 12, and my b is 1. So I'm going to have 4 and negative 3. And I have a leading coefficient, so it's 2x plus 4 and 2x minus 3. This reduces by 2, so I get x plus 2 and 2x minus 3. So my x's are 2, negative 1, negative 2, so plus and minus. I get the plus here and the plus here and the minus here, and then a 3/2. Next it says, use the remainder theorem to evaluate f of c at x equals c. So that's where we're doing synthetic division again. Make sure you fill in if you're missing anything. I'm missing an x to the third. And I leave it positive because that is my 0. It's not a linear factor, so I'm going to leave it positive. So I get a remainder of negative 23, and we write that f of 2 equals negative 23. And if you don't write this, you get it wrong. Next, we're going to use the factor theorem to determine whether the binomials our factors are listed. If the board ever changes. Just thinking about it. There we go. So I'm going to test, I'm going to start and see if this is a factor. I'm not missing any terms. So I have 3, 13, negative 32, negative 12. But this time it's a positive 6, so I'm going to test negative 6 because that's the factor. So this one is a factor. So if that is a factor, I'm going to use what's left now. And I'm going to test positive 2 this time. And then 2, this is positive, so this is 0. So this is also a factor. So I'm going to test what's left, which is right here. So 3 and 1, and I'm testing negative 4. So this one is not a factor because I had a remainder. Next, we're going to list all the possible rational zeros. So that's where we do P over Q. And this is P, and this is Q. So I want plus or minus all of the factors of 12. Plus or minus 1, 2, 3, 4, 6, and 12. And then my Q is 2, so I get plus or minus 1 and plus or minus 2. So all of my possibles are all of these, because they're all divided by 1. And then divide by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1. I already have that. 3 divided by 2. 4 divided by 2 is 2. I already have that. 6 divided by 2 is 3. I already have that. 12 divided by 2 is 6. So these are all my possibles. So next, I want to use Descartes' rule to give the possible number of positive and negative real zeros. So I'm going to do the positive first. So this is positive, positive. So here's 1 change, stays negative. There's 2, stays positive. So my positives, I have 2. And if I subtract 2, I get 0. So I have 2 or 0 positives. Next, I'm going to plug in a negative x into this equation. So after I plug that in, I get a negative 3x to the 5th plus 6x to the 4th plus 14x to the 3rd. This is positive, so it stays negative. This is negative, and that's positive. So let's check for our negative sign changes. So negative to positive is 1. Stays positive, goes negative, that's 2. Stays negative, now positive is 3. So my negatives would be 3, and if I subtract 2, I get 1. So it's 3 or 1. So if I'm given these zeros, write the polynomial function. So to get a negative 4/3, so if you have negative 4/3, oh, so if I have the negative 4/3, to get the linear factor, I will get 3x plus 4. So if this was set equal to 0, I'd have negative 4 divided by 3. And then I have a negative 1, so that linear factor is x plus 1, because it's the opposite sign. It's always the opposite. And this is a multiplicity of 2, so I have 2 of these. So if I multiply this out, I get x squared. 1 times 1 is 1. And then I get 1x plus 1x, which is 2x. And I still have to multiply that times 3x plus 4. So when I multiply 3x times x squared, I get 3x cubed plus 6x squared plus 3x plus 4x squared plus 8x plus 4. And then I'm just combining like terms. So 3x to the 3rd, I have 6x squared plus 4x squared is 10x squared. I have 3x plus 8x is 11x, and then plus 4. If I'm going to solve the polynomial inequality, first of all, this is less than, so I want negative, and I'm going to have open circles. I'm going to draw my number line and put the zeros. So I'm going to have negative 5, negative 3, and 4. So I'm going to test this interval right here. So I'm going to test negative 6. So if I put negative 6 in here, I get a negative times a negative times a negative. So this is a positive times a negative. This is the negative interval, which is what I want. So I'm going to do open circle, and these get included. So I have negative infinity to negative 5. Next, I'm going to test in here. So if I test negative 4, that gives me a negative times a negative times a positive. So this is a positive interval, so I don't want that. Next, I'm going to test in here. So if I use 0, I'm going to get a positive, a negative, and a positive, which gives me a negative interval. So I do want to include this. So this is open circle to here. So that's negative 3 to 4. And then I'm going to test over here, 5. That's going to give me positive, positive, and positive, which is positive, so I don't want that. So just, this is your answer. Oh my goodness, this board is going to kill me. The last one we're going to work on is the rational inequality. So the first thing you have to do is you have to factor the denominator. So if it's negative 8 and 7, it's going to be 8 and negative 1. So I have x plus 3 so I want negative answers, and so my 0, which is what I get from the top, is x equals negative 3, and this is going to be a closed circle. I want a closed circle because this is my inequality. It has the line. My vertical asymptote comes from the bottom, so x is negative 8 and 1, and asymptotes always get an open circle. So when you draw the number line, I'm going to put negative 8, negative 3, and 1. And the negative 8 gets a closed circle, the 1 gets a closed circle, and the negative 3 gets an open circle. Oops, I just did those exactly the opposite. Sorry guys, exactly the opposite. So one more time, the negative 8 is getting an open circle, the negative 3 is getting a closed circle, and the 1 is getting an open circle. So I'm going to test. If I test in here, negative 9, so on top I end up with a negative. On bottom I have a negative times a negative. So this is a negative divided by a positive, and this is a negative interval. And I want negative, so these get included. So I want negative infinity to negative 8. So then I'm going to test this interval right here, the negative 8 to negative 3. So if I pick negative 4, I have a negative on top. This is positive times a negative. So negative divided by negative, this would be a positive interval. So I do not want to include this. Next, I'm going to try in here. So if I pick 0, I end up with positive and negative. So this ends up being negative. So I do want to include this. So I'm going to have negative 3 to 1. And my last interval here, 2, would give me positive on top, positive, and positive. So this is a positive interval, and that does not get included.